Okay, next stop is going to be the last topic for the part 1. We already had part 1, okay? It's going to be class and object, okay? Okay, this one, let me just tell you first that you actually do not have to construct it. This one, I'm only teaching you because you are going to use it from the library scikit-learn. They use class programming. It's called the object-oriented programming. You might heard of the word OOP in your, I don't know, freshman computer science class, like computer class. That's what it is. So I got to teach you how it works, just enough for you to use it. So anything in here, like creating the class, you don't like creating the class definition, you don't have to do it in this course. Okay, so just relax. Okay, it's gonna get a little bit kind of strange, right? Because if you don't know much about OOP, it's quite the foreign concept to the newcomer, to the programming world. Okay, with that, let's go. Okay, I'm gonna do class.ipynd. Okay, so in the I guess in the paradigm of object-oriented programming, like everything is a class, like I tell you, right? When I say class, it means that it's there is the blueprint, the description of what the class is. What I say what the class is that what the class is more like a container of the data called attributes and the method, which is the function. So the thing about the class is that when you define it, you have to say what is going to contain in this class in terms of the data, and what can this class do in terms of the function. Okay, all right. It's probably gonna sound quite abstract, so let me just show you this one. Let me pull that one up. Okay, so if you want to define a class, just use the keyword class, okay, and followed by a class name, so my class. This can be any name. The convention is to start with the capital letter. So from now, if you see capital letter, so keep in mind that usually it's the class name, okay, and that's it. You can do colon. As with any kind of definition or control statements, you're going to do colon. And then if you do, I guess I have to select the kernel first for this to run. Okay. And then if I were to hit enter, you can see that my editor indented automatically, which is what I want. Okay. So again, if you do the class, if you want to define the class, you got to say what is the data inside it. So I'm do x equal 5. That's it. You got your class. Okay. So if I were to use this class, the above statement is just saying that this is the blueprint for the class. So this is not the actual thing yet. But the way that you do is that you gotta create the actual thing from that blueprint or from that design. Okay. And the thing that we're creating from that design is called the class instance. Okay, so I'm gonna create class instance. That's how it is. Okay, I don't know what's in Thai. เราก็เรียกว่า class instance นะครับในภาษาไทยนะครับ Okay, so the way we do this is that I'm gonna do my class, right? And then I'm gonna do that. So almost like a function, right? But this is technically not the function, but this is, I want to create the class instance from the class blueprint or class design. Okay, so let's just put this in another variable called p1. Okay, and just run that. Okay, so what is p1? Okay, let's just inspect it in our terminal. Okay, you're going to see that P1 has a type called my class. Okay, I want you to compare the similarity from here. If I were to do S1 equal string like hi, see what this is? S1 there's a type string. P1 type my class. So if you can see this, that means that if you see this comparison, you can start to notice that when you create the blueprint for the class, it's almost like creating a new variable type. It's like the custom variable type, right? So how do I use P1? Because P1 is a new variable type called my class, right? So I can do P1.x. Because P1 has something inside, we just tell the blueprint, right, that in my class, we're going to have x that is equal to 5, right? So then if I creating an instance from that blueprint, every instances of that blueprint should have x equal 5. That's the data inside the instance, okay? So if I do P1.x, I get 5. Pretty cool, right? You might be wondering, like, what's the use of this? Like, this seems obviously way too complicated, right? It's way too complex, right? But I'll introduce a more I guess, typical example later on, right? So you don't have to have just one. Data. You can do in this class. I want to have y equal 10, right? If I were to rerun this, right, and I create another instant P1, I don't need S1s anymore, right? I can do P1.x and I can do P1.y to be equal to 10. Okay? And also, if I were to do this, P2 equal my class, right? I create 2 instances of my class, right? Like that. I can do P1.x equal to 5. I can do P2.x also equal to 5. Not impressed, right? What happens if I do this? I can do P1.x equal 6. Now I'm changing the value of x in P1. You can try that. What happened? Right? And if I were to print or just do P1.x, definitely I should get 6. But what do you think should be P2.x? It's 5. You see what happened here? If I were to describe it in my, I guess, in my diagram, maybe hopefully this might help you visualize it better. So I have a blueprint. Okay, I'm going to use this color, maybe just like that, right? In here, I have x equal 5, right? And then whatever, x equal 5, right? So this is the blueprint called my class, right? Okay. And from that blueprint, I'm going to create the class instance. So I'm going to use maybe like that. This is the class instance. Okay. This class instance is called P1. So if this is creating from this blueprint, that means that it automatically get the design, which is x equal 5. So this one is x equal 5, right? But you can also create another instances called P2 from here, right? And from that, right? But the thing is that these two guys right here actually are separate. So it has its own attributes. So if I were to change it into 6, this thing still have 5, right? So as you can see that the way that the object-oriented programming works is that you define something here, and then you create the instance, and you use the instance to do something. For example, store the states. And also you can define some custom function for this instance to perform. And one of the examples that you're going to use all the time in this class is that this is machine learning model. This is how they define the algorithm of the machine learning model. And this is the actual model that you're going to fit to your data. So if you have data 1, you fit with this guy right here. You have another data, you fit with another guy right here. They're all separate. And the nice thing about this construction is that they all have their own states. So when you write the code, you have a lot of control. I guess you have a nice separation of your data. And that's the thing about OOP. I find it quite cool to write the program with. Okay? Okay, hopefully that helps you kind of appreciate, or I guess understand like why are we using this, okay? But this construction is too simple, because if we were to do this, then every class instance will get the same value of x and y, which probably not what you want. Same thing with the function, right? With the function, you want arguments so that your function is smarter. Similar with the class, we want class to be a little smarter, right? So we're going to use something called the constructor, okay? Right, so let me just delete this one because this one is too simple. I'm going to get rid of this. I'm going to restart them again. Okay, and a more typical class definitions are like this: person, okay, and function. First, we're going to have a function, and this is the default function called underscore underscore init underscore underscore and that one. And then when you have the function, you're going to have colon, okay, and then something in here, okay. So don't worry about the name because this is the keyword. So you have to use this one. You have to use this exact name. And this one is called the constructor, okay? So in the constructor, again, this is by design. So just bear with me for a second, okay? You're going to have something called self, okay? And then you're going to have other things that you want the class to have. For example, if I think about the person, I think each person should have name and should have age, okay? So that's something that describes what the person is. Like, actually, this is called the attributes, okay? And then what I'm going to do is that if I were to get the argument or the name and the age of the person, I can construct that person or the class instance by assigning it to its own attributes. For example, I can do self.name equal name. I can do self.age equal age, okay? I know this one seems really, really weird, right? So bear with me for a second, okay? Let me just complete them and hopefully it will make more sense, okay? Okay, so if I were to do this and I run this, actually this one is the complete class definition, right? Let's try to create the class instance from this definition, okay? Again, I'm going to use P1, person 1, right? And just like before, I'm going to have the name, and then I'm going to use the parenthesis, right? And if I were to run this, right off the bat, I will have an error. And if you see the error, you will find it very, very familiar with the error that you encountered just previously. Because it's saying that, wait, there is this function called init, right? And it's actually missing arguments. And that argument is name and age. This one looks very familiar with the one that we just saw when we talk about function, right? Because behind the scene, it's just a function calling, okay? So it's just saying that, wait, if you were to put anything in here, you have to supply me this thing in order for me to create the person. If I were to have more things, like for example, if I say sex, right? Then if I were to run this, now it's requiring 3 things: name, age, and sex. Okay, so that's what it is. Okay, so let's do just that. Okay, I'm gonna remove sex and then write that. So I'm gonna do again. I'm gonna use the keyword argument so that we know exactly what we're inputting. Name equal, and then run. Okay, and then age equal. I'm 41 years old. And now we can run it with no problems. Okay? So what it's doing, it's exactly what you see in here. So the name Nitran is going to go into this name right here. And the age of 41 is going to go into this age right here. And then what's going to happen is that this data, which is name, is going to get assigned to the attribute of the class person. And the age, which is 41, it's going to get assigned to the age attributes of this person. Okay? So I can come back here and say P1. If I were to dot, you can see that the editor is actually know what's the attributes, what's the available attributes of this class, right? You can do name, and you tap, right? And then you can do Nitran, right? You can do P1.age, and then you can press enter to get 41. Okay? So I think, yeah, I have the same thing, right? I have John and 36, right? So with this, you can actually create more persons, right? We can do another person. So maybe I'll just do everything in one line. Right? I'm going to print P1.name, right? I'm going to print P1.age, right? Like that. So pretty good. So there's nothing to prevent me from creating another person, right? I'm going to call it P2. And so I'm going to get another name, Tom, right? Another age, 20, right? And I can come here and say P2.name and P2.age, right? And it's going to be different, right? So as you can see here, that the way that we're creating the class is actually encapsulation of the data. So that's what it is for. Okay. All right, so let me show you one more thing just to make sure that you understand the concept of the attributes, right? What happened if I were to change this into name2 and age2? I can do that, no problem. Right, so you can try running it. I think if I were to change my class definition so that it's self.name2 and age2, then if I come here, then I will get error because the error is saying that right now I don't have attributes name, right? What I have, it actually has to be name2 and age2. Okay? So I want you to make some connection. If you were to change this name, you have to change this one when you call it, when you access it. Okay? So when I guess typically we use the same attribute name as the argument. So that's what most of the code will look like. But I just want you to make that distinction that actually you don't have to have the same attribute name and the argument name. It can be different. But it's actually quite confusing if you were to write the code like this. So nobody do this, okay? Okay.
I added also like after age the sex, but this is like not the same writing style like
yeah. Okay. So very good. So your friends, your classmates want to add another attribute. So how do we do it? Yes, certainly we can. Let's do sex, right? So I'm going to add sex in here. You can see that the color is a little different, right? And if you hover on it, you can say that sex is not access. Okay? Which means that you don't use this variable inside the function. So why is it here? I'm just it's called the editor kind of detect that you have unused variable. So let's use it. Okay? So I'm going to do self.sex equal sex. So if you used it, I just want to make sure you don't have to have the same attribute name. I can do sex2, okay, equal to sex. But this, the argument and what you assign it to have to be the same. But your choice of the attribute's name can be different, okay? And if I want to access the sex right now, I guess we have to do, for example, sex equal male, right? And then I can do p1 dot sex 2. Then I got male. Wait, oh, I forgot to run it. We have to run it too. Okay, I got it. And just to wrap things up in here, again, just to remind you that we don't actually have to create something like this in our class. We have to just use it. But I just want to tell you how it works, because then I guess if you want to dig deep into what it is, then you kind of understand what's inside, right? Last thing I want to mention is, what is this self right here? This seems really it's kind of weird, right? What self mean is self is the pointer back into the instant itself. So back into our diagram, right? If you have a class definition, what self mean is that it's gonna point into whatever instance you are working with at that moment. For example, if you call my class that are constructing this instant P1, that self refer to P1. And if you run another statement that you want to construct another instance called P2, that self is going to point into P2. So what the actual instance is, that can be accessed by the keyword self. Okay. That's it. Okay, maybe I'll just end it right there, because you don't have to know per se exactly what, I mean, you don't have to understand fully what it is, but this is how it works. Okay. All right, so let's do one more thing, because this is just the attribute, which is the data, but you can also define the method, which is another function. So you can do another function in here, and what I have it here is like my func, okay? And this my function is called, why do I name it like this? I should name something like introduce. Let's say introduce, right? That makes more sense, right? And then this is the function, and what's special about the function inside the class definition is that it has some access into self. And self is the instant itself. It's itself. มันคือตัวเองไม่รู้จะพูดยังไง มันคือตัวเอง It's self is itself. Okay? So if I want to introduce myself, what I want to introduce is that I can print, right, f string. I can print my name is, right, and I can do self.name too. See what I do here, right? Because if I want to introduce myself, I need to know what my data is. So that's why I get access to self, and then I can write anything that use my own data. And this data is gonna differ, you know, per instance. Like if you use another instance, it's gonna come up with, you can have another data. Okay. Just to make it a little more less confusing, let me just eliminate number 2, because this is not what I use in the example, and I'm probably gonna do remove the sex too, right? So like that, just to make sure that it aligns with my example. Okay, like that. Okay, so let me just continue, and then my I am, and then I'm going to do self dot age, right, years old. See the way that I do this? I have access to my own data. Okay, so let's try it real quick, right? I'm not going to print this one anymore, but then I can do, if I were to run this, I can do P1, right? It's a person named Niran, right? I do P1 dot, and now you can see that I got another method that I can use with my own data. It's called introduce, right? So I'm going to call this introduce, and then just like that with the parentheses, right? And there you go. I guess my name is Niran. I'm 41 years old, right? And again, if you were to do this with the other class instance, you can also do that. P2.introduce, and there you go. See, pretty cool, right? the thing that I really like about writing the program like this is that you have encapsulation, right? So you look at the code and you don't really, I guess you don't really have to supply, like once you create the object instance with the sufficient data, you can kind of design how your object is going to perform like action by just calling its method like that. And the code is really, really clean. That's what it is, okay? And you're going to see this pattern arising a lot in our machine learning journey, especially scikit-learn. They use this all the time. You're creating the class instance, which is the model you want to train. And then in that object, you have a lot of methods that you can use. For example, you're going to fit your data. You're going to make prediction. You're going to change the variable inside. Like everything that you do with the scikit-learn library, you do it like this. So that's why I'm saying you don't create anything, but you are using class all the time in this class. Using class in this class. Yeah, definitely, yeah. Okay, let me just introduce you to a more complex example. But this one, I'm not going to type anything. I'm just going to copy, okay? So I have another class called car, okay? And if you look at the definition, you can start, I hope you can start to be able to guess what the car has in terms of the data and what it can do in terms of the methods, okay? So let's do just that. Okay, I'm going to do this definition right here. And just look at it, right? You can see that the car has the brand, it has a horsepower, has color, and current position. So that's the data encapsulating in the car instance, right? And the car can also start, I guess, move forward and move backward. And as you can see that some of the method is actually going to change the current position. So if you create something like this, and when you write the code, you can see that the code actually very readable. I will show you, okay? So let me create a new car instance, right? This is just the design, right? I'm going to create the new car. So I'm going to do car1 equal cars with the capital C, which is the class instance, right? Again, I need to give them everything that is described here, okay? So I'm going to do brand, okay, equal Toyota, right? I'm going to do horsepower equal, I have no idea. I'm not good at car. I don't know what horsepower is, okay? And I guess I'm going to do color, okay? Color equal black, something like that, okay? So this is how I create the car instance, right? Okay, so what can I do, right, with the car? So I'm going to do car1 dot. See, first I can access the data inside my car because it's the attributes, right? The brand. If I do that, I should get Toyota, and you can try some other thing, right? Color, horsepower, right? And then also current position, 0, okay? But then what can I do with this? What can I interact with this, right? You can see that there are a couple things. I want to start, if I want to start the car, I can do car.start. And actually the editor is smart enough to know that I can start the car, okay? And then since this is the method, it's a function, you got to put in parentheses in order to call start the car. I guess this one doesn't do anything in terms of the data, but the thing that will change is actually this one, right? Move forward. If I were to move forward, right, I think move forward means that, it goes by horsepower, so just like that. See, I just move forward. And if I want to see the car current positions, then I can, it has to be just variable. See, it's 3,000, right? I can also say car1 dot move backward, and I want to print them right here, okay? And I can print again, like that, right? Just like that, okay? as you can see that if you write the class definition with all the things that it can do, right? When you actually come here and write the code yourself, like write the code in the main portion, it's actually very readable because everything is kind of encapsulated into the method. Like, okay, I'm gonna move forward. What is my current position? And then I'm gonna move backward. What is my current position? Like the code is actually very readable, and this is something that I like a lot in OOP paradigm. Okay. Okay, probably gonna give you a couple, I guess, if you want to try. If you see error, let me know. That's more fun. Mm-hmm. Okay, why can I just do this, right? But why there's no parenthesis, right? Like current percent. Why does this work, right? Without that, what do you mean?
Like in the example, you have the class car and then that in it, and then in the bracket, there's no current position.
Yeah. Okay. Okay. I forgot to tell you this because so. You can define as many attributes as you can. It doesn't really matter. I can even do a new one, like test equal yes. But if I were to do this, that means that these two attributes will will never differ between instances when you create it. So if you don't put anything, so if you put your variables in here, that means that you can specify the initial value. But if you do something like this, that means the initial value of the current position will always going to be 0 in every class instance. This is a way for you to specify the initial value of the class instance attributes. Right? So, and we do this all the time. Like in the model, machine learning model, there are things that we don't want user to set. We just hard code it in here. Not we, I didn't do it. The author of that library did it. Thank you for asking. Yeah, thank you. Yeah. Okay, so once you know the concept of the class, let me go back to the same page that I showed you before, this one. And now things will hopefully make more sense. This one. This is actually a class definition called logistic regressions. And these are the things that you can use to construct the class instance. So this is the machine learning model, right? And what we want to do is that we want to create the instance of this design with the initial value that we want. These initial values are the model parameters. So that's how we use the scikit-learn model. Like we do this all the time. So I'm going to go back to this to the document page just to show you that how you actually look up all the details of the machine learning model. It has the same format in all of the and actually in most of the machine learning model library, they also adopt this type of design. So once you're familiar with this, you can use other models too. It works pretty much the same thing. All right. Okay, so hopefully you have some experience with the class, all right? Last thing that I want to do is that I want to show you how to import it, okay? So I'm going to delete everything because normally we don't really write the class design inside our main program. Usually it's really long. So we typically put it somewhere else like this. See? You guys should have the file name called myclass.py in your folder. If not, let me know. You should have it. You don't okay, let me double check. If I go to cmu.2/AI class, if I go to code, and if I were to download this, let me just check if I have it or not. Okay. Wait, did I download it already? Yeah, it's actually right here. So can you re-download that zip file and make sure you extract? There's a file called myclass.py. So you probably missed it somewhere when you extract it. Yeah. Okay. So what typically happens in a lot of Python packages is that you don't write the class by yourself, but the class definition is written somewhere else. So that's why I'm putting it right here, just for example. You have the class definition here, and you want to use this class in your main code. So how do you import that thing into your code? So that's what we're going to try it here, okay? So I'll make sure I'll restart everything just to clean up, right? The way that I can do is that I can do from my class, and my class reflects the name of the Python file that I have here. So if I were to change my class.py into something else, I probably have to change from here too, okay? So I'm going to import, right? And I'm going to import car new, okay? So where does this car new come from? Let's go back to my class right here. See, my class.py, that's my class right here. The name has to match. And then this name, car new, has to match this car new. Okay, so I guess there's nothing secret about it. You can just look at the file and see that there are actually class car news in here. Okay, and the way that you use it from now on is just to call it or construct the instance from it. So I can do car1 equal car new, and then everything else you can have to follow what the constructor is doing. So I have to give them make, model, and year. So let's do just that. Make equal Toyota. Okay, and model equal, I don't know, Camry, and year equal 2024, something like that. And there you go. Wait, car new is not defined because I haven't run it yet. Go, done. Okay, so typically your code will look just like this. You're gonna import the class definition from somewhere else, typically scikit-learn library, and you're gonna use it like this, just calling the class constructor. I guess officially it's called the constructor, okay? Just like that. And you're done. And if you want to see what you can do with it, typically I will refer you to the documentation page like this one, right? But right now, if you have access to the source code like this, you can see that you can do get descriptive name. So I can do car1, get descriptive name, and voila, I got the name like that. So typically the editor is smart enough to inspect that for you, so it will autocomplete. So if you write just a couple characters, it will suggest you, and then you can tap your way to auto completion. All right, so I'm gonna expand it so that you guys can see what I did here. Okay. Okay, you guys get some error, or if you find, I want to show you a couple more things before we move on. Okay, so this one works, right? But I want to show you a couple ways that you can do imports. Okay, so this is one of the way. Another way is to import my class, just like that. This one pretty short, but if you were to do this, then you can say that now you have problem with this line right here because it doesn't know what car new is. So you're going to have to do my class dot car new. So if you want to only import just my class, then you have to specify my class dot car new, and that way it works the same way, right? So there's many ways to import the class definitions. And also, lastly, for some, I guess, unknown reasons, if you think my class is too long, I can do something like this. Import my class as another name, like my MC, just to make it more concise. And I can do mc.carnew, like that. So that one also works. Okay. So there are, I guess, 3 ways that I've seen in the code, so that's why I'm telling you that there are many ways. So typically you just copy paste from the code, from my codes anyway, but just be aware that there are many ways to import things from other files. Okay, and that should wrap up the part 1. So I'll give you maybe like 10-minute breaks and we'll come back to part 2, okay?